Hi guys! Salamat sa inyong patuloy na ginagawang pagsubaybay dito sa ating discussions about spiral transition curvature. Tayo ay nasa panglimang serye na ng ating discussions about spiral at ngayon ay mag-solve tayo ng sample problem para lalo nating maintindihan ang konsepto ng spiral transition curvature at kung papaano natin i-apply ang mga formula in dealing with this kind of problem. Here is our problem, guys. So, sabi dito sa problem, there is a spiral curve that is used to connect tangents having an intersection angle of 80 degrees at station 10 plus 100. It is desired that the maximum super elevation of 0.125 meter per meter is attained gradually within 80 meters. If the spiral shall be designed for a maximum velocity of 50 kilometers per hour, we are required to determine the following. First, we are required to determine the degree of the curve of the adjoining simple curve. We are also required to determine the intersection angle of the adjoining simple curve as well as the length of that adjoining simple curvature. Aside from that, we are also required to determine the spiral angle at the middle of the spiral angle at SC or at the point of the intersection of the spiral and the simple curvature, as well as the offset from tangent at the middle of the spiral and the offset from tangent at SC. We are also required to determine the distance along the tangent at the middle of the spiral, then the distance along the tangent at SC, and then the short tangent distance of the spiral, the long tangent distance of the spiral, and the tangent distance of the spiral. As a matter of fact, sa problem na ito guys ay parang ipinapahanap na sa atin ang lahat halos ng elements ng spiral transition curve. Kaya mas mabuti kung ah, sa ating analysis ay maipakita natin muna itong illustration para mas lalo nating maunawaan ano ba itong tinatawag nating kay degree of the curve of the adjoining simple curvature, how are we going to compute for this intersection angle, the length of the adjoining simple curve as well as the spiral angle. Ito na halos yung halos lahat ng ating element na ipinapahanap dito sa ating problem. So let us try to analyze by defining first our given. So we are given in the problem the intersection angle I, which is equal to 80 degrees. So let us try to have it in our problem. Okay, we have I. We are also given the stationing of the vertex. Okay, at 10 plus 100. So we write here the station V at 10 plus 100. We are also given the maximum super elevation, okay, of 0.125, and that is our E. So we will be writing our given here, that is E equal to 0.0125. And when we say attained gradually within 80 meters, we're actually referring to the length of the spiral. Okay, that is the distance that will connect the tangent, okay, to the spiral and the spiral to curvature. And we call this as L sub C. So we call this as L sub C. And we are also given that if the spiral shall be designed for a maximum velocity of 50 kilometers per hour, so we mean that we are given here the maximum velocity V, okay, which is equal to 50 kilometers per hour. And if this will be converted into meter per second, then we multiply it by the corresponding uh, conversion factor that for every 1 kilometer, there are 1,000 meters, and for every 1 hour, there are 3,600 seconds. And if this will be simplified, our maximum velocity will be at 13.88 meter per second. So you might be asking where will this be used? Of course, this will be used in the computation of our radius, considering that we have the maximum super elevation of 0.125 meters per linear meter. And from there, okay, after we have identified all the given, maybe we can now start drawing our spiral transition curve. Now let us try to consider our point here. Imagine that we have here our okay point where okay we have our tangent where our simple curvature will be drawn. Assuming that this will be the back tangent of the simple curvature. And then at this end of the curve, okay, it will be intersected by another curvature which will serve as the forward tangent of the simple curvature. Assuming that that is the point. And so from okay, somewhere here, okay, at the anywhere on the tangent, we can imagine that we have here our point of tangency. Okay, the simple curvature shall be drawn first para maunawaan natin dito paano i-connect siya with the spiral. And then from this point of tangency of the simple curvature, let us try to establish where would be the location of the center of the simple curvature by drawing okay, perpendicular distance to this tangent. So assuming natin that here is our perpendicular distance makatwid, somewhere along this line will be located our center of the simple curvature. Then from the same distance at this point, okay, a distance equal to this distance somewhere here, we can also establish our point of tangency of the simple curvature. And then from this point, by drawing a line tangent to this forward tangent of the curve, we shall be able to establish the location of the simple curvature, and this will serve as our center. So that maiintindihan natin dito that our curve will be a curve that will be drawn from this point, okay, smoothly towards this point of the okay, curvature. Okay, so that's what we will have. So ito yung ating simple curvature. Okay, if we are going to connect okay, a spiral, okay, from a spiral that will connect this simple curvature, as mentioned, that there will be okay, an 80-meter spiral. Ang ibig sabihin nun, okay, we'll be establishing paano natin ito i-connecta. So, in order for us to have a ideal okay, spiral transition curvature, let us try to connect the center of the circle and this vertex of the circle by straight line. Ano? So, kunin natin yan. And then, somewhere here, okay, dito natin makikita ngayon yung okay, intersection angle of the tangents to the spiral. So, assuming natin that, okay, here is our vertex. Ito yung vertex na sinatawag natin, which is at station 10 plus 100. Ano? And then, from this vertex, okay, we will be connecting the tangent to the simple curvature at this point, okay? So that from there, okay, may establish natin yung tangent distance ng ating spiral. Ito ngayon yung tinatawag nating tangent distance ng spiral. And because we are given in the problem that the spiral has an angle equal to 80 degrees, so that okay, itong point na ito and this point will be connected, and the line that will connect the 2 points will have a total angle of okay, 80 degrees from this tangent of the spiral. So we will be connecting it with this so that our I is equal to 80. Sa makatuwid, ganyan yung magiging simula, and we will expect therefore that our spiral will start at this tangent, itong tangent nitong pagsisimulan ng ating spiral. Assuming natin that somewhere here, okay, will be the location of our position where spiral will commence. And then from this point, we will be drawing a line that is perpendicular to this tangent para ma-establish naman natin dito yung center of the spiral. Okay? So, if we will be looking at that point, ito yung ating magiging T sub S. Okay? Itong point na ito, masasabi natin ito yung ating okay, SC, itong point na ito. Ano? And then it is now connected with the simple curvature. So the end of the simple curvature will now be called, na kanina ito tinawag nating PT. Ito ngayon tatawagin natin itong curvature to the spiral, or the intersection between the curvature and the spiral, that is equal to CS. And from the CS to another point on this tangent, okay, we will be connecting again with the spiral on the other side, the length of which is given to be 80 meters. Kaya pag i-connecta natin yan in this way, so at this point, ito yung tatawagin nating spiral to tangent. Yan naman yung spiral to tangent. Kaya makita natin, nabuo natin yung ating connection. This length from this point up to that point is our spiral connected with a simple curvature, and then from the simple curvature, we have another spiral on the other side of the curve. Di ba? So, yung ating sinasabing length of the spiral ay magsisimula dito sa TS. At na-mention doon sa ating given that the length of the spiral is 80 meters. That means the total length from TS to SC is equal to 80 meters. Yun yung ating given. Di ba? And then from there, ipinapaharap na nga sa atin yung elements of the spiral. Ano? So, pwede nating solve siya. Mag-start tayo with the radius of the curvature. But because we are given the super elevation and the velocity, okay, masosolve natin ngayon yung ating radius. Itong radius na ito, yung pinakamaliit na radius ng ating spiral, which actually, okay, the radius of the simple curvature. And how do we solve for this? So, since we know that, okay, the super elevation is equal to the square of the velocity divided by kg times the radius of the curvature. Because we are given and we have computed the velocity, we will simply substitute the value here, okay, and the super elevation as well as the acceleration due to gravity. So that from this, we can solve for our R sub C representing the radius of this curvature. So substitute natin yung value dito. Okay, so we shall have here 0.125 representing the maximum super elevation. Our velocity is at 50 kilometers per hour, converting it into meter per second. That is multiplying it by 1,000 and then dividing it by 3,000. So the resulting unit above, okay, of the numerator or the velocity will now be in terms of meter per second. Dividing it by 9.81 times R sub C, since R sub C is the only unknown, so we can compute for R sub C to be 157.1 meters. Alin yun? Ito ngayon yung tinatawag nating R sub C. Yun yung length itong curvature nito mula sa SC hanggang sa center nito. So ito rin yung R sub C natin. Ano? Okay, that is 157.31. Now, after you have computed for R sub C, so makakompute natin yung degree of the curvature of the adjoining. This is the curve, and so this curve will have a degree based on the radius of the curvature. And how do we solve for that? So sabi dito, to solve for the degree of the curvature, we use the formula, the relationship that the degree of the curvature is equal to 1145.916 divided by its radius. And because the radius is already computed at 157.31, then the degree of the curvature will be equal to 7.284. So, paano natin ito papaliwanag itong 7.284? Ang ibig sabihin nito, for every 20 meters of this curve, okay, that length will be subtending an angle equal to 7.284 degrees. So, that is the degree of the adjoining, okay, simple curvature. Next, what shall we do next? So from there, we can already solve for the spiral angle at SC. So kinakailangan ma-define natin ano ba itong spiral angle at SC. Now, let us try to imagine that we at SC, we try to consider and to look, okay, the tangent line at SC. And if we are going to look at that, we are actually defining this line, which is the tangent distance tangent to the simple curvature. Okay, the angle that this tangent is making with respect to the tangent to the spiral, this angle is actually our S sub C, or the spiral angle at SC. And this spiral angle has a formula as we have already derived from our previous discussion that SC is equal to LC over 2RC, na kung saan itong LC is the length of the curvature, the length of the spiral from TS to SC. And given in the problem, this is equal to 80 meters. So that, okay, we can now compute for that SC. Of course, this SC is expressed in terms of radian. Ano? So you will be having 20 divided by 2 times 157.310. So if that is in radian and converting it into degree, we simply multiply it by 180, okay, divided by pi, and so that our spiral angle at SC is given, is computed at 14.57 degree. So this angle is actually 14.57 degree. So that is, of course, the first element of the spiral that we have computed so far. Okay, aside from, of course, the element of the simple curvature that is joining this spiral. So from here, we can also compute for the intersection angle of the simple curve, itong angle ng simple curvature. Kasi importante that we will be able to compute for that. What we have actually is the intersection angle of the spiral, which is 80. And so from this 80, okay, we will be solving this okay, intersection angle of the simple curvature. So ipakita nga natin yan dito. Ito yung tinatawag nating I sub c, no? Yan yung I sub c natin. And we are asked to solve for this. How much is that? Okay, let us try to imagine that we draw the center of the spiral. Ano? So at TS, okay, this is taken by drawing perpendicular line. As well as at ST, when we draw perpendicular at ST, therefore, the total angle that is subtended by this curvature, the combination of the spiral, the simple curvature, and the spiral on the other side is actually our spiral angle. Ito yung ating I na 80 degrees. Di ba? And because we have computed the spiral angle at SC, okay, ano bang relation niyang spiral angle at SC in the spiral? Actually, this spiral angle is also this angle. Okay, the angle that is subtended by the line, okay, joining or the radius of the curvature at SC and okay, the radius of the curvature at TS. So this is our SC, which is already computed at 14.57. On the other side, this is also our SC at also the same magnitude at 14.57. And because the total angle, okay, from this point up to that point is also equal to 80 degrees, hence we can compute for the okay, intersection angle of the simple curvature, as this will be equal to, okay, I sub c equal to I, this one, minus twice of our SC. And if we will be substituting the value, okay, we can compute for I sub c to be equal to 80 minus twice of 14.57, and this will give us a value equal to 50.86 degree. So we have our okay intersection angle or the central angle of the simple curvature that joins the spiral. Okay. So next we can compute for okay, the next element, the length of the simple curve, as we have computed for our spiral angle, I'm sorry, intersection angle. We can now compute for the length of the simple curvature. The total length from SC to CS, which is equal to the same formula that we have used in our simple curvature, equal to 20 multiplied by I divided by the degree of the curvature. Okay, when we substitute the computed value for I and that of the degree, we shall have our length of curvature equal to 20 multiplied by 50.86 divided by 7.284. So that our length of the curvature will be equal to 139.646 meter. So ito yung 139.646 meters. Okay? So after we have computed for this okay, length, what can we compute? So we can now compute for the spiral angle. Okay, one of the unknown, the spiral angle at the middle of the spiral. Since our spiral has a total length equal to 40 meter, therefore, okay, at the middle of the spiral, somewhere here, okay, we are looking for the spiral angle. Okay, meaning the spiral angle at L equal to 40. And how are we going to show that? So if we will be locating this point on the spiral, okay, this point in the spiral, and we try to draw a line that is tangent to the spiral, passing through this point, we shall have this, okay, tangent. Ito yung ating L na tinatawag nating 40, and our spiral angle will be shown by this pinakikitang okay, line drawn tangent to that spiral at L equals 40. Okay, that line. Ano? And therefore, our spiral angle will be the angle that this tangent is making with respect to this line. So ito yung ating tinatawag na spiral angle at 40. And how do we compute for this? There is a formula that we have derived. And this S can be computed by the formula L squared over 2 LCR sub C, where L is the length of the spiral at that point, okay, at this point, and that is equal to 40. Yung L sub C naman, ito yung length of the spiral at SC. Yeah, and we will have here okay, an angle expressed in terms of radian again. So if we will be converting it into degrees, we will be multiplying it by 180 over pi. So that when we substitute the value, okay, we shall have our, okay, 40 square, okay, divided by 2 times 80 times 157.31, okay, multiplied by 180 over pi, giving us a value of the, okay, spiral angle at L equal to 40, and this is equal to 3.64 degrees. Itong S na ito is actually 3.64 degrees. Di ba? Now, after we have computed for that, okay, anong ating pwede ngayon makompute from the requirement, we shall be solving for okay, the offset from tangent at okay, L equal to 40. That is at the middle of the spiral, since the spiral has a length of 80 again. So ibig sabihin, we are defining how far is this point from this tangent. That is the offset from tangent. Let us call this point as yung x. Ano? Let us imagine that that point is the x that we are actually seeing in our illustration. Okay, and how do we compute for that, okay, x? So we can compute for that x, okay, using the formula that is L cubed over 6 L sub c over R sub c. Again, yung L sub c natin is the length of the spiral at SC, R sub c is the radius of the curvature, and L is the length of the spiral at, okay, the point where the offset is being computed, and that is equal to 40. And when we compute again for the value, that is 40 cubed over 60, or 6 times 80, okay, times 157.31. This will give us an x, okay, equal to 0.85 meters. So this is actually 0.85 from, okay, the tangent. Okay, so after we have computed for this offset from tangent at uh, the middle of the spiral, we can also compute for, okay, the offset from tangent at SC mula dito daw naman. Okay, measured from our tangent. So ito yung tinutukoy nating, okay, offset from tangent at SC. And we call that as X sub C. Ano itong X sub C na ito na nagbibiling sa ating illustration. Okay, and how do we compute for this x sub c? So we can compute for that x sub c using the formula that, okay, x sub c is equal to LC squared over 6R sub c. And if we will be computing, substituting the values, that LC is equal to 80 and RC is equal to 157.31, then our x sub c will be equal to 6.781 meters. This distance, okay, is 6.781 meters. Ibig sabihin, the point SC is 6.781 meters away from, okay, the tangent distance of the spiral. So after we have computed for that, what can we compute now? We can now compute for, okay, the distance along the tangent at L equal to 40 at the middle of the spiral, meaning if we will be measuring, okay, the distance of this point from TS measured towards, okay, along this tangent distance, therefore we are actually looking for the distance along the tangent. So we will be representing it here. Let us try to show it here. Ito yung distance na yon, okay, then that distance na tinutukoy natin na itong tinatawag nating y. Ano? Yung y na yan. And there's a formula for y, that y is equal to L minus L to the fifth over 40 L sub c square multiplied by R sub c square. And if this will be substituted, our L is the distance 40, di ba? Ay yung L sub c natin is 80, R sub c is 157.31. So that this will have, okay, a value when substituted, 40 minus 40 to the fifth over 40 times 80 square times 157.31 square, giving us a value for y, okay, equal to 39.38. Similarly, we can compute for the offset from tangent at SC, meaning to say the distance of this SC as measured from TS along this tangent. So tingnan natin itong part nito. Ito yung tinutukoy natin. Ano? Ayan. Yan yung ating y sub c. And y sub c will have a value by substituting L sub c to L in the formula. And this will be equal to L sub c minus L sub c cube over 40R sub c square. So that this can be computed. When substituted, we have 80 minus 80 cube. over the quantity 40 times 157.31 square. And the value for y sub c is equal to 79.483 meters, meaning this S sub c is 79.483 meters from TS measured along this tangent line. Okay, so that is how we compute for the distance along the tangent. And then we can also have, okay, our computation for the short and long tangent distances. Ano? Maaaring tanong nyo, ano ba yung short and long tangent distances? Ganito yun. So if we will be drawing a tangent, okay, tangent from SC, okay, pakita ulit natin yung tangent from SC na yan. Ayan, no? Nakita nyo yung gumuguhit na ko. Yan, ano? Yan. You will notice that this SC now, this spiral transition curve will have kay tangents on it. Meron tayo ditong tangent mula dito hanggang diyan at mula dito hanggang dito. In my case, ay medyo confusing whether which one is our long tangent and which one will be our short tangent. But this that can be defined by the angle that we will be getting if we will be analyzing this further. Ano? Makikita niyo later on. Now, how do we do it? Okay? So, if we will be joining this TS and SC by a straight line, so makikita niyo ngayon yung triangle na mapo-form. Ano? So, there will be a triangle that will be formed, okay, from the computed value of y sub c and of course ating x sub c. So, ito yung triangle na blue shaded triangle na nakita natin na pinapakita dito. Okay? Do you see and recognize, identify the triangle? So, in the triangle, meron tayong okay, given sides okay, na y sub c which is computed at 79.483 as well as the side which is computed at 6.781. Hence, okay, in this triangle, we can compute for this distance TS to S sub C using Pythagorean theorem. Hence, we can solve for that okay, using Pythagorean theorem that it will be equal to the square root of 79.483 okay, square plus the square of 6.781 meters. So that the distance will be equal to 79.77. This line will be equal to 79.77. Yeah? Now, pagkatapos niyan, since we will be looking at which one is our tangent, long tangent and our short tangent, then let us now try to consider the other triangle, itong tinatawag na shaded triangle na ipapakita ko sa inyo. Okay, nasaan siya? Ito yan. Okay, nakita niyo yung triangle na yan naman. Okay? So, in the triangle, okay, we already have just computed this distance, 79.77. Ang aalamin natin, which one of the two will be our long and the short. Okay? So in my case, medyo mahirap ma-identify. Ano? In my drawing, mahirap ma-identify. But we shall be able to identify that later on. Okay? As okay, we will define the angle that this triangle have. Ano? So puntahan natin itong angle na ito. Hindi ba itong angle na ito is naipakita natin kanina? Okay, pakita natin kanina. At na-compute itong ating S sub C, which has a value equal to, okay, S sub C, ano? So that this angle will be the supplementary angle with S sub C. And this will be equal to 180 minus S sub C. And this angle will be equal to our I sub C. Itong I sub C natin, ano? Okay, I sub C yan. At alam naman natin yung I sub C base doon sa ating na-derive na formula last time in our previous discussion. This I sub C will be 1/3 of S sub C. 1/3 nito. Ano? Yung S sub C is 1/3. Okay? So pagkatapos, kaya makita natin yung triangle angle na ito, let us try to define that this angle is equal to theta. Diba? And from here, we will be defining this angle theta. If we shall be able to compare the magnitude of this theta and this angle I sub c, then ma-define natin alin ba sa dalawang tangent na ito ang long at ang short. Ano? So let us try to look at this angle. So we will be solving for that angle using that green shaded triangle. Okay? We understand that the sum of all the angle inside the triangle is equal to 180. Therefore, there will be relationship that we can establish between I sub c, this angle, and that, and the sum of which must be equal to 180. So let us try to establish that. That is the sum of theta plus I sub c plus that angle 180 minus S sub c will be equal to 180. So from here, 180 will cancel. So that S sub I theta will be equal to S sub c minus I sub c. But I sub c, alam natin is equal to 1/3 of S sub C. Hence, yung theta natin will be equal to 2/3 of S sub C, or if we will be substituting the value of S sub C, it will be equal to 9.71. So nakita natin na itong S sub C o itong theta is greater than I sub C. Kasi yung I sub C natin will only be 1/3 of 14, ba? And 1/3 of 14 is all about something about 6 point something. Sa makatwid lalabas na since theta is greater, therefore its opposite side will be greater than the opposite side of our I sub C. Hence, this distance will be our TL and this distance will be our T sub S. Di ba? Hence, we can compute that, okay, those value by using our sine law, that the ratio of TL to the opposite of its subtended or included angle, ano, the opposite angle will be proportional. So that TL over sine of theta is proportional to TS over sine of I sub C and proportional also to the ratio of 79.77 divided by sine of 180 minus SC. That if this will be substituted with the value, we can solve for TL, okay, which is equal to 53.48 and TS, which is 26.85. Ito yun, 26.8. Kamakatwid, itong distance na ito will be our TL and that distance will be our TS. Diba? And then finally, from here, we can solve for the tangent distance. Diba? Ano ba yung tangent distance? Mula dito sa TS hanggang sa vertex. And we have the formula that the tangent distance, ipakita natin yung tangent distance. Yan, mula dyan, ito yung ating tangent. And this is computed by considering this distance which is equal to L sub C over 2. And this distance will be equal to R sub C plus X sub C over 4 times tangent of I over 2. Hence, our tangent distance by copying that relationship in the figure, that is L C over 2 plus the quantity R sub C plus XC over 4 times tangent of I over 2. And if all the value that we have computed will be substituted here, okay, we shall have, okay, the value LC over 80 over 2 plus 157.31 plus 6.781 over 4 times tangent of, okay, 40, because 80 over 2 is 40. And from here, we can solve for the tangent distance to be 173.42 meters. Okay? So that is how we solve, okay, the problems on the spiral, particularly the different elements of the spiral transition curvature. And I hope that with the presentation of the sample problem I gave you, you are able to understand how do we use the spiral, how do we compute for the elements, as well as the different elements of each adjoining simple curvature. Sana ay patuloy niyo akong subaybayan sa pamamagitan ng pag-subscribe sa ating channel at kung kinakailangan, share it to your friends so that they may also know this kind of discussion that we have in this channel. Once again, thank you very much for watching.